All right, so this is a slideshow for practice on solving problems for Chapter 7.1 and 7.2. So this is called a uniform distribution, and this distance here, if you notice, between 50 and 51 is 2. And the area under the curve is considered to be 1, so the area of the rectangle is 1. So when I take 1 divided by 2, I get 0.5, and that gives me my p of x, the constant probability of 0.5. So if I want to know the area under the curve from here to there, so for 51 to 54, it's 0.5 times 0.5 gives me 0.25. So what that means is the probability that the class length is greater than 51.5 minutes is equal to 0.25. So the probability that the class lasts for more than 51 minutes is 25%. And that's how you use a uniform distribution. So the key is finding the time duration and dividing it into 1, and that gives you your constant probability. All right, here's the normal curve, and you guys know from before that this is the mean, so mu equals 0, and then this is 1 sigma and 2 sigmas and 3 sigmas, and each one of those sigmas stands for a standard deviation. So you're like 1 standard deviation, 2 standard deviation, 3 standard deviations, and you remember that the area from 1 above and 1 below, remember that was 64%, and then from here to 2 standard deviations was 95%, so that this distance all between these two guys was 95, 0.95 or 95%. So that was that. And you remember the 3 was 99.7 or something like that. I can't remember. But it's not important. But that's the idea. Is the z-score just tells you what area under the curve is happening. So here we go. We want to look at a z-score between this. So this is the probability that 0 is less than z is less than 1.97. So I want to draw a picture of that. So here's 0. 1.97 would be right about there. And it wants to know this area under the curve. Well, to do that, I can use the table. I'm going to go get the table over here. So I need to find the z-score for 1.97. So I'm going to go down here to 1.9. Keep going. Here's 1.9 over here. And 1.97 would be 0, 1, 2, 3, 4, 5, 6, 7. So it's 97.56. So a z-score, or the area under the curve with a z-score of 1.97 is 97.56. So I'll go back to my picture here. So I know that this area here is 0.9756. And I also know that this area here is half 0.5000 because, it's halfway across the curve. So if I take this is going to be equal to, this area here is going to be equal to 0.9756 take away 0.5000. So if I do 5 take away from that, I end up with 0.4756. So let me go back and check my z-score one more time, make sure I got that. 97.56, and I think that's what I wrote down, 97. Okay, so now let's go use the calculator. So we want to find the z-score between 0 and 97. So I turn this guy on, I can click clear, second distribution, number 2. So it's called a normal CDF, and if you read your book, it tells you that. It tells you to put in the lower bound, comma, the upper bound, 1.97, and then close that parenthesis, and that gives you the area between the curve of 755.8, and the 8 rounds it up to 56. So you get the same answer. So that's how you do it with the table, and that's how you do it with the calculator. So I've done both ways. Now let's go down to the next problem here. So I want to find the area to the right of 1.09. So here's 1.09 is right here, 1.09. And the area to the right is over here. Well, the table only gives you the area to the left. So I'm going to go over here to the table, and the table, if you go up here to the top of it, it only gives you the area to the left. So I want to find the area to the right, but the first thing I want to do is find the area to the left. So if I look up 1.09, that's 8721. So 8721. So this is the 9's column, the 8 column, 7, 6, 5, 4, 3, 2, 1, and 0. So 1.09 is 8621. So I want to go back to my thing, and so 8621. So this area over here is 0.8621. So that area that way to the left. But I want to find the area to the right. So the probability that z is greater than 1.09 is going to be equal to 1 minus 0.8621. All right, so if I do that, I get 0.1379. All right, so 1379. So I'll do it with the calculator now. So second quick clear. And then second distribution, number 2. And I want to go from the lower number is 1.09. So 1.09. But the upper number would be 3, but I'm not going to use 3. I'm going to go way out here to 999. I'm going to use 999. I think that's what they recommend. TI recommends it in the book, I think so. So I get 1378. But then the 5 rounds it up to a 9, so I do get the same answer roughly. All right, so that's how you do it with the table, and that's how you do it with the calculator. One more thing about the table that makes it kind of slick. I'm going to show you this on the table. I'm looking up 1.09, and I got 1379. You can also go to the table and look up negative 1.09. And so this is why the table is sometimes quicker than the calculator. If I look up negative 1.09, I get 1379 right off the bat. And bam, I'm done, son. Boom, 1379. So that is a trick way to do it, because the graph of this is symmetric. So this is negative 1.09, and since I'm finding the area to the left, it's symmetric with this area over here. They're the same. Same. So that's a trick that you can use if you get good at doing this stuff. All right, so here we want to find the area to the left of negative 0.64. So negative 0.64 is right about here. Negative 0.64. So I can go to the table, and negative 0.640123 so 2611. So 2611. 0.64 is 2611. And by the way, if I scroll up a little bit, maybe I'll be able to see it. Usually it'll go off the screen. Of course it does. But the reason I'm going over to the 5th column is because that's the 0.4 column. So that I can't see both at the same time, but anyway. So 0.64 is 2611. So I go back over here to my picture, and I know that this is 0.2611. So the probability that z is less than negative 0.64 is equal to 26.2611. All right, so I can go back to the calculator here. Second distribution, number 2. And I can put in my lower number. Well, because my lower number, I don't have one, so I'm just going to use negative 999. So negative 999, comma, 0.64. Ooh, I want negative 64. So negative 0.64. And I get a number here of 2610, but then the 8 rounds it up to 2611. All right, so then let's do another example here. All right, so we want to do the probability that's between 1.23 and 1.9. So 1.23 and 1.9. So what I'm going to do is find the area from here over, which is in the table. So I want to find the area to the left of this. So I'm going to get that number first. So let's go over to the table, and I want 1.9. 1.9 is 9713 right here. So I'll go back to the chart. So 9713, so 0.9713. And then I want to find this area here, which is 1.23. Or no, it's not 1.23. It's going to be less than 1.23. So I go back over to the table. So what did I say? 123. So 1, 2, 0, 1, 2, 3, so 8907. So 0.8907. So the probability that 1.23 is less than z is less than 1.90, and that's how you write it algebraically, is going to be equal to 0.9713 take away 0.8907. So we can just knock that out over here. So 0.9713 take away 0.8907. So I get 0806. So this is equal to 0.0806. So I do it that way. You can also do it in the calculator with second distribution number 2. Lower bound is 1.23. Upper bound is 1.9. And I hit the go, and I get 0863, and round it off to the four decimal places. You get the same. All right, going down here, I want to find, this is kind of right, I want to find to the left of negative 2.5, so that's right here. So negative 2.15. And to the right of 1.62, which is over here, 1.62. So I want this area over here and this area over here. So the probability that z is less than negative 2.15 or z is greater than 1.62 is going to be equal to the area's total. So I'm going to use the table. Now remember, I can look up negative 1.62 and get that area right straight up. So I'm going to go up here and look up negative 1.62. So a little bit more here. Negative 1, well, a little bit more. Negative 1.62 is 0526. So 0526. So this area over here is 0.0526. And then I'm going to look up negative 215, so I'll go back to the table. 215, negative 215, negative 21, 0, 1, 2, 3, 4, 5. So that's 0158. So that's going to be 0158. So 0.0158. So it's going to be equal to 0.0526 plus 0.0158. All right, so then I take these two guys and I add them together. So equal to 0.0526 plus 0.0158. Add those guys together, and I get 0.0684. Now, there is no simple way to do this in the calculator. I guess you could do it the long way. Remember, this is negative 999 over here, and this is 999 up here. All right, so I'm going to go second distribution number 2. I'm going to find this one first. So I go negative 999, comma, negative 2.15, close that, add second distribution number 2, and then I got 162, 1.62, comma, 999. Close that. Now I've used the curve, the function twice, and I get 0683, but I have to round it up, so 0684, so I get the same answer. All right, so that's how you do it both ways. All right, so now we have an application problem. All right, I'm not going to do all three of these. I'll just do one of them and see what we get. The average CEO is 56. So that tells me that mu is equal to 56. And assume the variability is normally distributed. If the standard deviation, so sigma, is equal to 4, find the probability that the age of a randomly selected CEO will be in the following range, from 53 to 59. So I want to find the probability of that. So first of all, I have to find the z-scores for these two people. So the z of 53 is going to be 53 minus 56 divided by 4, which is going to be negative 3 over 4, so negative 0.75. And then the z of 59 is going to be equal to 59 minus 56, all divided by 4. and that's going to be 3 divided by 4, which is 0.75. So what I want to do now is I want to find the area between the curve. Here's my mean. It's 56. Also 0 if it's a z-score. All right, this is 59, and this is 53, and this is negative 0.75, and this is 0.75. So I found out all of that information. Now I just have to find the area between these two z-scores. So I go over here to my calculator. I'm just going to use the calculator. I'm not going to mess with the table. So second normal distribution, number 2. So I get negative 0.75, comma 0.75. Hit the go button, and that tells me that the probability that 53 is less than x is less than 59 is equal to 0.5467. 5467. Alrighty? And so no rounding up on that. So there's a 54% chance that your CEOs are going to be between 53 and 59. There is another way to use the calculator to do this, and you could also use the table. But another way you could do it is second distribution. We're going to compare the answers. So I put in my lower bound, which would be 53. I put in my upper bound, which is 59. Then, because this normal CDF defaults to a mean of 0, then and a standard deviation of 1, if I force it to use the standard deviation, the mean of the problem as it's given, so 56, comma 4, it will reevaluate these numbers, and it gives me 5467, 5467. It gives me the same answer. But I have to force the calculator to do that by entering these numbers that are given in the problem. So that's a way to use the calculator to save yourself a little bit of work. But then if you do that and you make a mistake, then I got nothing to grade. All right, so next problem. I'm not going to do these two. They're the same thing. All right, so the average commute one way is 25 minutes. So mu is 25.5, according to the 2000 census. If we assume that the commuting times are normally distributed with a standard so sigma is equal to 6.1. What is the probability that a randomly selected commuter spends more than 60 minutes a day commuting? So P of T greater than 60 is what we want to find. So we're going to draw our beautiful curve. Here's 0. That's 25.5. That corresponds to 0. And then we're looking at a timing of 60, so we want this area over here. I need to find that z-score first. So z of 60 is going to be 60 minus 25.5 divided by 6.1. So that I'm going to use the calculator for. Clear. So I got 60 minus 25.5, and I get that number, and then I divide by 6.1, and that gives me, holy moly, 0.5655. Now that's a lot of that. Oh, that's not even right. It's 5 point. Oh my God. It's 5.6555 and some change. Okay, so that's my z-score. All right, so I'm going to go over here and hit second normal distribution, number 2, and I'm going to go 5.6555. I know what's going to happen. Comma 999, and I get whoa. So I get this probability is equal to a 7.79 times 10 to the minus 9. So that means like that's 0.1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 7, 9. So that's pretty much not happening. Okay, so wait. Let's try it with the other way here and see how close we come. So do normal CDF. Remember, we wanted the lower bound was 60, comma 999, comma, and they said it was 25.5, comma 6.1. Okay, so we got that number. Do we get the same answer? 778. Well, pretty close. 7 times 10 to the minus 9. We get about the same thing. So pretty much, if the average commute is 25 minutes and you're not spending 60 minutes, you're lying. Alrighty. Right. To qualify for security officer training, recruits are tested to stress tolerance. The scores are normally distributed with a mean of 62 and a standard deviation 8. All right, so we know we got a beautiful curve, and this guy is 62, and we want that's the norm mean. We want it if the top 15% of recruit. Okay, so they want the top 15%. So this is 0.15. So we want to. It corresponds to a z-score, or the area under there that corresponds to a z-score of 15%. So in order to do that, I'm going to go back to the table. Oops. Go back to the table, and I want to find 15% inside here. So 0.1, 0.1, 0.15. I'm looking. Okay, so here I notice I got 0.151, and I got 0.1592. This is only 8 away from 0.15, and this one's 15 away from 0.15. So the answer is somewhere in the middle. So I'm just going to go with the closest one. So negative 1.0. 1, 2, 3, 4. So negative 1.04. So negative 1.04. So I'm going to go back to my drawing here, and this is negative 1.04. So I know that's the z-score that corresponds to that. I can also do that with my calculator by going second distribution, and this time I use inverse norm, number 3, of 0.15, and that gives me 1.036, which I round off to the 0.4, and so I'm good to go. I've got the same answer 2 ways. So what does this mean? That means my z-score, I want to find this number here. So my z-score is negative 1.04 is equal to x, the number I'm trying to find, minus 62, divided by my standard deviation, which is 8. Now to solve this, I times that by 8, so negative 1.04 times 8 plus 62 is equal to x. Now they have a fancy formula in the book, but what I just did was multiply both sides by 8 and then added 62. No big deal. All right, so 8 times the answer, so that's 8 times this, plus 62, and I end up with 53.7. So 53.7 is equal to x. So the score, all right, so a score above 53.7 would be needed to be in the top 15%. Okay, that's how it works. So P of x greater than 53.7 is equal to 0.15, and that's what we just found. All right, a certain normal distribution of 1.25% of the area lies to the left of 40. Okay, so I got to draw a picture here. Well, we know we have 40, and then there's 50. Okay, 1.25 area, so this is 1.25, right? And 1.25%. Ooh, that's really small. My picture's way off here. Let me redo that picture. So 1.25%. Ooh, it would be way down here. So that's 1.25%. So my 40 is going to be way over here, and then this guy's over here is 50, and this is also 1.25%. So that's equal to 0.0125, which is really small. Find the mean and standard deviation. Well, the mean's not too bad. So the mean happens when this is 0. Right? So then the middle of these two guys is 45. So that's the mean. And then I don't know how many standard deviations this is. So I'm going to go, I need to find a z-score over here. So I do know that see, I need to find a z of 1.25%. So second vars inverse norm of 0.0125, right, is -2. So this is -2.24, and this is 2.24. Now I can do it with, let's go look it up in the table. Let's go see if we can find it in a table. So 0, 12, 5. So 0, 12, 0, 12, 2. Oh, look at that. 0, 12, 5 is right there. Huh. I'll be danged. That doesn't happen very often. So that's -2.2, 1, 2, 3, 4. 2.24. Hey, that's what we wrote down. I'll be darned. Okay. So, and then we know by symmetry this is 2.24. So we know that 2.24 is equal to 50 minus 40 times standard deviation. We'll call that our x. So I'm going to flip around these guys. So x is going to be equal to 50 minus 40 divided by 2.24, which is 10 divided by 2.24, which is going to be 10 divided by 2.24, which is equal to 4.46. So the standard deviation is about 4.46. There you go. So I found the mean by just finding the middle of those two numbers. So that's my mu. Oh, and the mean is 45. All right. All right. An instructor gives a 100-point exam in which grades are normally distributed. The mean is 60 and the standard deviation is 10. If they're okay, so we have a beautiful curve. We already know the mean is 60. So that's 60. That's 0 for our standard deviation normal distribution. And they want to know the 5%. So 0.05. So I have to go find that z-score, right? So remember, that one, that number there, I need that z-score. I'm going to find the z-score for, A's are 5%, and then 15% are B's. So 15 back here. So that would mean this area corresponds to, so the area going this way would be 0.20, right? So then, that'd be 80%. And then the C's are 60%. So okay, so that if this is 50, that's 30. So this would be over here. So this would be 60 right here, 60%. And then I'd have that guys there. That's my, and here's my F's. My F troops are over here. So that's 0.05, and then from here over is 0.20. All right. So how am I going to find these? This must be like 30 and 30. So this distance here is 30. This one here is 30. All right. So I want to find those z-scores. All right, so top 5%. So I'm going to inverse norm that. Second distribution, inverse norm of 0.05. That's going to give me a negative number, so I just know that this is 1.645. All right, then I'm going to inverse norm 20%. So second inverse norm 0.2. Oops, go to, what did I do? Oh, wait a minute. Second quick clear. Inverse norm, number 3. So 0.2, and that's a -841. So this score is, the score is -8416. So that's this guy. Well, not negative, it's positive, my bad. So then this makes this guy negative 8, 4, 1, 6, positive, negative. And then this guy actually starts right here. Oops, hey, we're on the last slide. This goes here, right, like that. So I don't need this thing. So I need this one. Oh, I know that one's negative 1.645. So there's my F, D, C, B, and A. Okay, so I need those cut scores. So I want to find these scores as we go, right? And once I find one of them, well, once I find my standard deviation, I can figure the rest of it out. Right? So here, I know that 1.645 is equal to x minus 60 divided by 10. So 10 times 1.645 plus 60 is equal to x. So I'm going to go over here and say, all right, that's not too bad. So 10 times 1.645 plus 60. So that's 76.5. So A's are 76.45. Now F's, I just go second enter, and I just make that a negative. So second insert a negative, and that makes a 43. So 43.55. Now where do the B's start? All right, so I got 84. So I got 80.8416 is equal to x plus 60, or x minus 60, all over 10. So 10 times 0.8416 plus 60 is equal to x. So I got 10 times 0.8416 plus 60, and that gives me 68.46. So this is 68.42. Now I just take this and hit second enter and use the symmetry in my curve here, and second insert a negative there, and that makes D's are 51.58. And so then, and below. So the C's are all between here. So C's start. So I go, it kind of goes like this. So this is 76. 76 is that, and B's are here. And then these are, oops, these are the C's. These are the D's, and then the F's are below there. So there's my breaks. So this kind of makes me wonder, can you imagine a class where we require you to have exactly 20% of people fail the class? I mean, that's what that means. And you have to give a test so that, and curve it so that 5% fail. And whenever somebody says, could you curve the test? I don't curve tests for that reason, because I'm requiring 5% of you to fail and 15% or more to have to repeat the class, which just doesn't make any sense. All right, that's the end of this one.